We can create Venn diagrams by listing the elements, and we can also create Venn diagrams representing the number of elements that are in each region of a Venn diagram. So we're going to use an example to show how we can use a Venn diagram both ways here. I'm going to begin always by drawing the big rectangle that's going to represent my universe. And I notice here that my sets are A and B. And by default for our class, I'm just going to always have you draw our circles as overlapping. If it turns out they don't have any elements in common, then we'll just leave the overlapping part blank. So first, to fill this in, I'm going to look for where do my two sets have the same elements. So A is in both sets, C is in both sets, and E is in both sets. And when an element is in both sets, it will sit in the overlap, so it will be here. Now it's time to determine which set is going to be A and which set is going to be B. I'm going to call this set on the left A and the set on the right B. So the entire circle in red here, that entire circle represents A. Now I've already listed the elements A, C, and E in that part of set A that does overlap with part B. And so the remaining elements from set A, which are elements B and D, will go in the part of set A that is not overlapping with the set B. And when I look at set B, I've already listed A, C, and E, but I have not yet listed G and H. And I take a look at set B and notice that set B is this whole circle, so it contains two regions. It contains the region where it overlaps with set A, and then the region where it does not overlap with set A. So A, C, and E go in the overlap, and G and H go in the part that does not overlap. And now I want to see, did I get everybody? Because if there's anybody that's in neither of these sets, then it's going to go out in that space outside of the circles. So I've got A somewhere in there, I've got B, I've got C. I'm going through and I'm looking at everything inside my Venn diagram circles, and I'm crossing off everybody. But I notice that F is not listed there. I've got B, D, A, C, E, G, H. None of those are F. So therefore, F is sitting out here. Now, that's a Venn diagram that actually lists the elements where they go. I can also represent this idea by saying how many are in each place. So I can do the same work and say, well, there are two elements here, B and D. There are three elements there, A, C, and E, and there are two elements here, G and H, and there's one element out there. And those numbers should add up to how many are in the universal set. Now, we typically create the Venn diagram based on the information we're given. So if we're given information about the actual elements, then we write down the actual elements. So this is really the way we would create a Venn diagram for this example. But sometimes you will be given information about the number of elements in each region, and then you'll create a Venn diagram that represents the number of elements. Our next topic is operations on sets. So just like you can take numbers and add, subtract, multiply, divide them, you can do certain operations on sets. And they're not quite the same operations that you can do with numbers, because they are collections of objects. So we can't necessarily think of them as quite the same way as numbers, but we can still do various operations on them. The first one is called the complement of a set. And the complement of a set is the set of all elements from the universal set that are not in the set. And it's denoted A complement. Sometimes I read it not in A. The union of two sets, which is denoted A union B, is the set that results when you combine all elements of the sets together. And the intersection of sets, which is A intersect B, is the set of elements that are in both A and B, or the overlap. So let's take a look at an example. For the set here, U is all of the elements that are listed anywhere on here. And remember, capital A and capital B are the names of those sets. So U includes all of the letters that you see. And once you go through and you put them in order, you'll see that all the letters would include A, B, C, D, E, F, G, and H. If I want to find A, then I make sure that I include every element that's listed in either of the two regions that I see for A. So everything that's inside the red circle. So that would include B, G, E, and H, but it's nice to put things in alphabetical order. So just pause and make sure that you are writing them down in alphabetical order, not just the order you see. Let's skip ahead to D, and we're going to come back to part C. For D, we're looking at identifying B, set B. So set B includes H, E, and F, which if we write it in order, it would be E, F, H. So now for parts C, E, and F, I'm going to practice using set operations. And for C, I'm going to show a little work down below. So for C, I would recommend that you list the universal set. A, B, C, D, E, F, G, and H. And then I would recommend that you list A, which is B, E, G, and H. And to find a complement, you want to find a complement by crossing A's elements off of U. So I'm going to cross off B, because that's an A. I'm going to cross off E. I'm going to cross off G and H. And what's left in U is going to give me a complement. So the ones that are left are A, C, D, and F. And notice that A and A complement will never have any elements in common. And when you put them back together, they'll make the universal set. Now, to find A union B and A intersection B, we want to focus on these two sets. So remember, our definitions are that the union would be the set that results when you combine all elements of the set together. So that means that anything that shows up in either of those highlighted sets is going to show up in my union. But I'm just listing who's there. I'm not going to, for example, list E twice because it shows up in both, or H twice. I'm just going to say, well, A is not in there, so I'm not going to list it. B's in one of them, so it goes in. E is in one of them, so it goes in. G is in one of them, and F is in one of them, and H is in one of them. So I end up with this list, which is basically what happens when you combine or merge the two sets and you put them in order and you don't list anything twice. Now for A intersect B, I'm looking for which ones are in the overlap. So the overlapping elements would be the ones that show up in both places, which would be E and H. Now I've done all of this without really mentioning the picture very much. So let's go through that picture and make sure that we see where the complement for A is, We see what the union looks like. We see what the intersection looks like. So first off, we're going to use red highlighting, and then we'll erase it in a second, but let's use red highlighting to represent a complement. And I'm not going to worry about, what the letters are. I'm just going to notice that if it's not inside A, then it is in the region outside of A, which is going to be all of this out here. So this is the region outside of A. And the only elements that are in that highlighted region are A, C, D, and F. Now, if I want to do the same thing for the union, if I want to find the union of A and B, it means I'm going to look at combining these. So I'm going to look at merging all of A with all of B and looking at that whole big group together. And so that's going to give me B, E, F, G, and H. And finally, we're going to take a look at the intersection. And the intersection is where do they overlap? So visually, that's going to be this region right here, which is E and H. Now, there are a lot of great problems in your book to practice with, so I recommend at this point you turn to your book and look at pages 105 through 108 and work through numbers 1 through 14. Really work with this level of understanding for a while before you move on, because it can get very confusing to try to do the more complex operations with Venn diagrams when you're just getting a sense of what's the complement, what's the union, what's the intersection.